Right, continuing on now with accessing components. Let me get a share screen. So the interaction between scripts requires that we have a way of communicating between them. We can access components, for example, a transform or a light or a collider or one of our own scripts, such as the follow that we just wrote. These can be accessed through the get component function. Variables we can access through the exposed public variables that are visible in the inspector. And objects, individual objects, can be accessed either by their name or by their tag. There's also some access by type too as well. So recall the look at example that we had. We had the follow script. It had an exposed variable, the target, and all it did was look at the target in every update function. If I add to the spotlight the switch A script, which has itself a public transform switch to target, and in my update function here, when I press the jump key, which is the space bar, I'm going to get the component follow. That's the script, the other script. And I'm going to access its target, its exposed variable, target. And I'm going to assign to that exposed variable this target I want to switch to, the switch to target. And so if I look over here at switch A, switch A, I have to stop playing here and move to the switch A scene, not the switch A script. So here's my player. Here's my spotlight, and I have the follow script that is following the player. And I've added the switch A script, and the target I want to switch to is the sphere. So now when I play this, it's currently following the player, but when I press the space bar, it switches to the sphere. So these two scripts have communicated through their exposed variable. They've accessed each other through the get component, and then they've assigned something to the exposed variable from within the script. If a slight modification so that when I release the jump button, it reverts back to the original. What I'm going to do, I have a private variable, original target, that in the awake function, I catch by, again, getting component follow and accessing its exposed variable target. And then in the update function with the jump, I now have an else clause that sets the follow target back to the original target. So this is switch B. And now if I play this one and I press the space bar, it switches to the sphere. If I release it, it goes back to the player. And I can, of course, move around. It's following me while the space bar is not pressed. It's following the sphere when it is. An aside about the various forms of the get component and many other functions with generic forms. These will be referred to in documentation with a angle bracket and a T. And these generic functions, their return types can be assigned kind of at runtime. So this is completely legal to say get component rigid body, assign this to object, which instead of having an explicit type of rigid body, just uses the var keyword. This actually works. Uh, this can save a bunch of keystrokes, and that instead of having to say rigid body RB is a cast of rigid body and type of rigid body, we can just say rigid body RB is get component angle bracket rigid rigid body. Any of these would work. Hinge joint hinge is get component type of hinge joint as hinge joint. Hinges get component as hinge joint, but we can use the var form, or we can use the explicit type form with the get component and the angle bracket form. Now, there are a lot of variants of get component. There's get component in children, which finds the component in the game object or any of its children. Get component in parent is in the game object or any of its parents. So in one case, we're searching down the tree, and the other up. We also have the plural form of get components that returns an array of all the components of that type. And we have get components in children and in parents that returns that array. You remember with the rag dolls, I said one of the things you might do with a character is make it into a rag doll, set all of its rigid bodies to be is kinematic, and then when the character dies, go through and release the is kinematic condition so that the character then falls apart and slumps to the ground. So here, get components in children rigid body goes into this array of rigid bodies. It has the angle brackets. I go through all of those. This is in the awake function, and set the is kinematic to true. That would make the animator control our character. And then in the update, if I press the R key, it's going to go through each rigid body, each RB in rigid bodies, and set them all to false. So that's a possibility. Incidentally, with the get button down and up, get button jump, is it pressed? Get button down, the jump is when it is pressed, and get button up, jump is when it is released. All of this with the space bar. So we can get really fancy now. We can switch by name here. We're going to catch the original target, same way we did before. But the switch to target is no longer an exposed variable. Instead, I'm going to find it by its name. Incidentally, when these variables are private, one thing you can do is try debug mode, in which case the private variables become visible, but you can't edit them. They're uneditable. We'll switch C by name here. No, I want to get switch C by name. Switch C by name. So if I go into debug mode here, now I can see the original target here, but it's grayed out. This is a private variable, private member variable, but it's grayed out. I'm going to leave that back at normal. Okay, so in the update function, when I press the jump button, I'm going to look for a transform new target. And I'm going to use the game object find to look for an object whose name is a sphere. Here it is over here, the little a sphere that I want to switch to. And I extract out of that game object its transform. And I assign that to my follow script target, and away we go. And of course, on the else clause, return to the original target. So this is going to work exactly the same way as the other one did. I press space bar, and it goes to the sphere. It's found it, in this case, by name, and it's returning to its original. So I don't have to set a target, I just have to give it a name. The find method is somewhat expensive. Finding a game object by name means that I'm searching through all of the objects in the world looking for an object with that name. If there's more than one object with that name, it'll return one of them, but you don't know which one. If no game objects with name are found, it returns null. And again, because of this business of having to search for everything in the world, it's not something that you recommend doing every frame. Another way to do this is to find objects with tag, find with tag. Now, objects have tags. Let me go into my switch by tag scene here. Now my sphere has a tag sphere. This is a custom tag that I made for it by adding a tag. There's also these other tags that are kind of built in, but I added one called a sphere. It doesn't have to be the same name as the object. It just turned out that way. So the find with tag, again, will return one active game object that's tagged tag. If there's more than one, it'll return one of them. Again, we don't know which one. And again, it'll return a null if they're none. Tags are declared in the tag manager of the player settings. So switch by tag, again, awake is the same. We're just catching a copy of the original target. And here now, instead of a game object find, I have a game object find with tag. This is now a tag, not the name of an object, but everything works exactly the same. And this will function exactly the same way as my find by name one did. It switches to the sphere and everything works cool. Now, in the same way there's get components that return an array, there's find game objects with tag, just this little S here. And so this returns an array, a list of objects, and null if none of them were find. But this means that we can get really fancy and put a lot of A-sphere tagged objects around our scene, not necessarily named A-sphere, they're just tagged A-sphere. And we can search that list, say for the nearest one. So we'll find the one that is closest and assign that as our target. So that's this scene here. I've got all these A-spheres, A-sphere 1, 2, 3 through 6, all of which are tagged A-sphere. So not much difference here in switch closest. I've added an array of game objects, GOS, and I've also added a game object closest. And again, I've made these public just so I can see them in the inspector. They could as easily be private. And in awake, I catch my original target. In update, when the jump button is pressed, I'm going to set my new target to be the return value of find closest with its transform extracted from it. Everything else is exactly the same. And find closest is a function that we're going to write. So find closest, it's returning a game object whose transform is we're extracting. So its return type is game object. It uses the find game objects with tag a sphere, loading them into the array GOS. It sets distance to be math infinity, mathf infinity. This is the largest float. And it catches a copy of the original target's transform position. So that's presumably the player, since that's what we were looking at to begin with. Now, now that we have this array of game objects, it's going to go through those game objects using a for each game object GO and GOS's, form a vector that goes from the game object GO to the position that is my original target position. Um, and I'm going to find the square magnitude uh, of that vector. This could all be done in one little line, but I've broken it up to make it clearer. Now I did this diff square magnitude because I only really care who's further away than whom. I don't care about the actual distance. So by using square magnitude, I avoided that costly square root. If I found one that's closer, I replace GO with, or closest with GO, and I replace distance with current distance, and I keep going around through my list. When I'm done here, closest should contain the object, the game object that was closest, and I'm returning that value, uh, and uh, and uh, and it appears back here in it reappears here in find closest, and I extract the transform of that because the new target has to be a transform. So let me summarize what we did. We have a function that returns something, a game object. It's the closest object that has a tag A sphere. We used a list or array of game objects. We used a mathf infinity function that gave us the largest float. We looped on items in the list with a for each. And we formed the difference between two positions, 2 points define a directed line segment or vector. We found the magnitude squared of that vector, and we extracted the transform of that closest game object in the return there. And let me show you this. If I press the space bar, it goes to the closest one. If I move so that a different one is closer, it adapts and moves to the closest one. And of course, if I release it, it goes back to its original. That's pretty cool. So I'll stop there. I'm going to stop sharing at this point, and I'm going to end the recording, and I'll see you all in class. Goodbye.